Phoenix is the first Mars-bound mission. It's the first mission that's going to try to land near the North Pole of Mars. And it's the first mission that's actually going to go try and reach out and touch water on the surface of another planet.
Where there tends to be water, at least on Earth, there tends to be life. And so it's potentially a place where life could have existed on the planet in the past.
The main purpose of EDL is to take a spacecraft that is traveling at 12,500 miles an hour and bring it to a screeching halt in a soft way in a very short amount of time.
We enter the Martian atmosphere. We're 70 miles above the surface of Mars, and our lander is safely tucked inside what we call an aeroshell.
Looks kind of like an ice cream cone, more or less.
And on the front of it is this heat shield, this saucer-looking thing that has about a ½ inch of essentially what's cork on the front of it, which is our heat shield. Now, this is really special cork, and this cork is what's going to protect us from the violent atmospheric entry that we're about to experience.
Friction really starts to build up on the spacecraft, and we use the friction when it is flying through the atmosphere to our advantage to slow us down.
From this point, we're going to decelerate from 12,500 miles an hour down to 900 miles an hour.
The outside can get almost as hot as the surface of the sun.
The temperature of the heat shield to reach 2,600 degrees Fahrenheit.
But the inside doesn't get very hot. It probably gets about room temperature.
There is this window of opportunity within which we can deploy the parachute.
If you fire the chute too early, the parachute itself could fail. The fabric and the stitching could just pull apart. And that would be bad.
In the first 15 seconds after we deploy the parachute, we'll decelerate from 900 miles an hour to a relatively slow 250 miles an hour. We no longer need the heat shield to protect us from the force of atmospheric entry, so we jettison the heat shield, exposing for the first time our lander to the atmosphere of Mars.
After the heat shield has been jettisoned and the legs are deployed, the next step is to have the radar system begin to detect how far Phoenix really is from the ground.
We've lost 99% of our entry velocity. So we're 99% of the way to where we want to be. But that last 1%, as it always seems to be, is the tricky part.
Now, the spacecraft actually has to decide when it's going to get rid of its parachute.
We separate from the lander going 125 miles an hour at roughly a kilometer above the surface of Mars, 3,200 feet. That's like taking 2 Empire State Buildings and stacking them on top of one another.
That's when we separate from the back shell and we're now in free fall. It's a very scary moment. A lot has to happen in a very short amount of time.
So it's in a free fall, but it's also trying to use all of its actuators to make sure that it's in the right position to land.
And then it has to light up its engines, right itself, and then slowly slow itself down and touch down on the ground safely.
Earth and Mars are so far apart that it takes over 10 minutes for a signal from Mars to get to Earth. And EDL itself is all over in a matter of 7 minutes. So by the time we even hear from the lander that EDL has started, it'll already be over.
We have to build large amounts of autonomy into the spacecraft so that it can land itself safely.
EDL is this immense technically challenging problem. It's about getting a spacecraft that's hurtling through deep space and using all this bag of tricks to somehow figure out how to get it down to the surface of Mars at 0 miles an hour. It's this immensely exciting and challenging problem.